Hi, good morning everyone. Today's experiment is Pinacol rearrangement. So we're converting Pinacol to Pinacol. So systematic name is 2,3-dimethyl 2,3-butane diol, which is Pinacol, 2,3,3-dimethyl 2-butanol, which is Pinacol, with sulfuric acid as a catalyst. Okay, so we do the distillation today, simple distillation to collect the product, because diol, which has a high boiling point, become a ketone, which is low boiling point. First, we add 5.9 grams of Pinacol, okay, anhydrous Pinacol, means no water. So weighing papers. Pinacol is like a crystalline. Okay, transfer this solid into 100 milliliter round bottle flask. Okay, when you transfer the chemicals, don't do it on the hot plate, heating methods, because your spirit damaged. So slowly adding it to a round bottle flask. Make the weighing papers like a cone shape. It's easier way to transfer solid into a small mouse flask. Okay. And then we add 20 milliliters sulfuric acid, 20%. Okay, so which is aqueous. So sulfuric acid inside is catalyzed the reaction. Okay. Don't forget to adding boiling chips, maybe 2 pieces, 3 pieces. Yeah. Don't add too much. The boiling chip gives the homogeneous boiling. There's no splash. Okay. So when you set up the distillation, don't do everything all together. Just one by one from the heating source. Okay. First, round bottle flask. What's the next? Yeah, next one is 3-way adapters. Okay, 3-way adapters. So we have to greasing it. Every connection with the paper can be there. You have to greasing it. Also, when you distillation, the temperature is hot. Sometimes the glassware is melted and fused. So the grease prevents the fusion of the glass pieces and also prevent the escape of the vapors. Okay. How do you know it's enough? After you're spinning it, you see the clear transparent surface. Or if it's enough grease is there, it's not easily off. Okay, there's nothing there, but it's not. But if you add not enough, it's easily this glass piece is off. Okay, detached. So that's another way to do it. Next, connect the condenser. This condenser is different from the reflux condensers. This is thinners. Okay. So reflux column is thicker, but the distillation condenser is thinners, and there's nothing inside. Okay. So there's a difference. Maybe you can use the reflux columns for the condenser, but this is the problem. Okay, so since the vapor can hit there, so you greasing there. And spinning. And see the grease is spreading, and this is not easily detached. So that's enough. But make sure we have rubber bands around it. So there's no chance it's fall down. And then thermometer adapters and thermometers. This is 3 pieces. Okay. This is up. This is one adapters, and this is another joint. So there's a big hole. There's a small hole. The big one, the glassware, and through the small holes, thermometer going in, top to bottom. Okay. And since this area also vapor is formed, so you have to grease it. 2, 3 places, a little bit each. Slightly push down and spinning it. Okay. First, you have to see the grease is spreading. Yes. And it's not easily detached. Okay, so it's good. It's not a glue, but if it's enough, it's not easily opened. Okay, fine. And the position of the thermometer is also very important to read the temperature correct. So, top of the blue one, okay, top one should be bottom of the side of 3-way adapters. So going in. So that's the correct position. So top of the blue there is bottom of the side. So level should be matched. Okay. Okay. What's next? Next is vacuum adapters. So it's curved and will be connected here. Okay. We need a grease here. Usually we don't need it because this condensed liquid is falling down and it's not a hot area, so you don't need it. But to make sure it's not fall down, you need a rubber band to connect it. Okay. Yes. Okay. And then it's connected to 25 milliliter amber flask. We collect about 10 to 15 milliliter of distillate, so 25 is good enough size. Maybe we collect about half of the size, and maybe around between 10 and 15. Okay. And since the product is a little bit volatile, we keep it in ice press. So we can prevent the vaporizing. Okay, evaporation. So looks like everything is set except water. So to cooling the system, we need the water going in and out. Remember, water always going in from the lower place, and water is out to higher place. And sometimes water tube is off, so there are many techniques used, but my favorite is put the rubber band on top of the water tube, so it's a kind of holding it. So this is water in, going in and go through it, and water come out, okay, to the sink. So turn on the water. Water is filling. Okay, everything is set. The condenser is full of the water. Okay. Now turn it on. Let's set to 70 to 80%. Wait until we collect the product. Okay, whenever you collect the product through the distillation, you have to mention which temperature ranges you collect your distillate, your product. Okay. So when you start to collect, like first 1 or 2 drops collecting into the flask, you check the temperatures. And when you turn it off, when it's done, check the temperature. So in your report, you have to mention which temperature ranges you collect your product. Any ranges. Okay? Because different ranges, different compound amount. So we are waiting. Okay, the solution starts boiling. The Pinacol with this diode, boiling point is over 170 degrees Celsius. But our product, Pinacol, boiling point is about 106. So as soon as the product forms, it is laid off. And this one coming together with water. We have that much of the product so far. Okay, so this is right a bit you see the fume steams, they're mostly the water. So it looks like organic compound is completely transferred. So reaction is complete. And also we got about more than around half of the flask, which is about 13, 14 milliliters. So I think we collect enough. So now stop heating, and then remove the heating source to make it fast. Okay, solution stopped boiling, so it's a little bit warm, but still no they stop boiling. So now we get our product. In case the product still come out, just turn it around. And we got about the half full of the flask, so maybe about 12, 13, 14 milliliters. We transfer into a separator burners. At this point, because we're using the sulfuric acid as a catalyst, so a small amount of the sulfuric acid can come together. So there may be some sulfuric acid. So to remove or neutralize sulfuric acid, we add 10% sodium bicarbonate, okay, which is a weak base, 10 milliliters into the flask. So there may be acid-base reaction, and especially you will see a lot of bubbles. So there are two layers. One is the organic layer, which is product layer, and the other one is aqueous layer. Because when you distill, water coming together, because water has a low boiling point than your product by 6 degrees. So density of our product is about 0.8 gram per milliliters, and water is 1. So we can see the top layer. Top layer is our product layer, organic layer, and the bottom is aqueous layer. So shaking a little bit. Okay, when you shake the separator burners, it's up and down, not the side to side. Okay. Always use 3 fingers to holding it, 3 fingers to control the barrel. And don't point the tip to your partners or some other group people. So where there's no one is there, because sometimes liquid is shooting like water because of the pressure inside. So be careful. Okay, open the stopper and wait until organic and aqueous layer is completely separated. And remember, whenever you do extractions, whenever organic layer touched by aqueous layer, small amount of the water mixed into organic layer. Although the organic and the water, they are separate like this, but small amount is always inside organic layer. So after this extraction, we have to remove the water in organic layer using drying agents. Okay, so don't forget that. And since the bottom layer is our waste, we just put into the waste containers used. So this will go to waste bar. And okay, so top layer will be collected into aluminum flask. Okay, move to the side. Okay, so this organic layer looks okay. It's kind of clear, but it's not perfect. So there are small amount, maybe not much. The water improves. So we add sodium sulfate, the drying agent. How much? Depending on how much water there. So first you add small amount. And the sodium sulfate is crystal, looks like a sugar. So if you're adding it, can you see the big chunk there? Can you see it? Big one? There, there, there. That's the one absorb the water. Okay, in the middle, there's a big one. If you see the small crystals, which is water free. So if you see small crystal, that's extra. So there's no more water, but this sodium sulfate cannot grab the water from the organic layer. So that means it's enough, and the solution is clear. Okay, so and leave it there for 1 minute. So it will be completely dried. After this, we will do second distillation. Okay. Our organic layer is dry, so we transfer it to 50 ml aluminum flask for second distillation. So just decant. Don't forget boiling tips. Okay, position it. This is three-way adapter. We need a grease, of course. Spin it and make sure it's enough good. Okay. Condenser, just same we used. Rubber bands, okay, bands. Thermometer adapters, also you're spinning it. Position of thermometer is okay. This is the final product, so we need to know how many grams of the product we got. So we collect it. in the beakers. Okay, so before we start, we have to know what's the weight. So make it 0. And it's 28.57. So writing down somewhere. That's empty one. Okay, so it's ready. 7. This is the final product. So definitely you have to recording which temperature ranges you collect the final product. Okay, it starts boiling. Okay, it's around 100 degrees Celsius. Under 5. Stop at 105. So the product coming out at 105 degrees Celsius. Now it's 106. When you do the distillation, make sure this reaction flask should not be dry. So at least small amount of the liquid should be remaining there. Okay? Don't dry. Don't heating until all the way to the end. So you have to keep watching it. Okay, 106. It's almost dry, so I have to turn off. Okay. I wait until it's cooled down. So we collect our final product between 102 and 107. 107 is a little bit higher than the boiling point of heater. So mostly the distillate temperatures remain around 106, but at the very last, a little bit changed to 107. Okay, looks like cool down. So we take this product out and keep the water on. Okay. Make 0. We know the empty beaker weight was 28.57. And together with the product, it's 32.45. So 32 and 45. The difference is 3.9. So our final product, we got 3.91 gram of Pinacol. 45. Okay, good. Okay, this is the end. So now be careful because this is still hot. It's time to clean up. Clean up is as important as doing the reaction, because if you don't clean your glassware as researchers, when you try the new reaction next time, you have to clean. And the glassware is not dry. So whenever you finish, make sure you clean everything, so every glassware should be ready to use anytime. It's very important.